Okay guys, so let's get into this. So today we're learning about scatter plots. What is a scatter plot? So a scatter plot is a type of graph that shows how two sets of data are related to each other. To create a scatter plot, we need to have two sets of data, like I said, one for the x-axis and one for the y-axis. So, if you're wondering how to remember what's the x and what's the y is to the sky. And also on a treasure map, x always marks the spot and it's always on the ground, okay? So we have those two sets of data, and usually speaking, we have a dependent and an independent variable. So the independent variable, that's usually what we put along the x-axis, so along the bottom, and that's the variable that may cause or influence change in the other variable, which is the dependent variable. And that is the result that may have been changed because of the independent variable. Very confusing, I know. And we put the dependent variable on that y-axis here. Now, to explain a little bit, I've got this beautiful table here. Now, this is looking at the number of hours studied and the test score between A classes. It's just a made-up scenario from my good old friend AI.
Love AI.
And essentially, if you have a look here, we've got the number of hours studied in this column here, and then we've got our test score. And then if we come down, I'm going to essentially say put a little scatter plot on here. We can see that along the x-axis, we have the number of hours studied. So that may cause change in our test score. Then you see along the y-axis, which is here, all right, we've got our test score. We can see that as we increase our number of hours of study, test scores increases. It's a beautiful thing. It's a very beautiful thing. Okay. So now we're going to get into how do we actually make one of these with our calculators, because they are a beautiful thing, calculators, and they can do so much for us. So let's get into it. Okay, so we've got a question here that I'll explain how I guess we make our scatter plots on our calculator, because they are so powerful and do so much for us. So we've got the scores awarded by two judges in an ice skating competition are shown in the table. We've got Judge A, all the scores that they gave out, and Judge B and all the scores they gave out. Then there's our competitors here. We've just randomly assigned them a letter for anonymity's sake. The first question is construct a scatter plot with Judge A's scores on the horizontal axis and Judge B's scores on the vertical axis. So we jump over to our trusty Casio calculator and we put the data in. So for Judge A, we put that in list 1, okay? And then for Judge B, we jump on over and we put that into list 2. Okay, so we've got our two sets of data. List A is always our x-axis, and list 2 is our y-axis. Then we're jumping over here, we go graph 1. And you see, wowzers, beautiful, perfect, okay? Yeah, we've got that fantastic scatter plot just made there for us. And then copy and complete the following comments about the scatter plot. So this is asking us whether there's correlation. Now I'm going to put some images on the screen here. As you can see, when there's a bit of the kind of data is just going in a flat line, we would say that's neutral correlation. When the data is going in an upwards trajectory, like our fantastic graph here, all right, that means the data is going in a positive direction. If this were to be the opposite, we would describe that as negative correlation. Okay, so positive or negative correlation are the two words. And basically, we also want to describe the strength of them. So if you have a look at the images on the screen here, we've got two different types of positive correlation. You can see one, the dots are in a very straight line, whereas in the other one, they're kind of like scattered out, but they are heading in that upward trajectory. So that's where we describe the strength of that correlation. So is it strong? Is it moderate? Is it weak? Okay. And then obviously for the opposite, so I can show you some images here. This is where we've got strong, moderate, or weak negative correlation. Now, the last question is, would it be reasonable to conclude that an increase in Judge A scores caused an increase in Judge B scores? Well, based off the data we have here, yes, it would be okay to assume that. As we can see, as one judge's scores increased, as did the other. The reason for that is because more than likely the dancers or the ice skaters, they were just performing better. So it's not like they were judging differently. They were judging the same. So they were accurate judges. Well done to them. And that's how we create scatter plots and start to interpret some data. And we're going to get into the real nitty gritty with scatter plots. So get excited for that.